We're going to be graphing y equals negative 1/3 x for the absolute value of x plus 2 minus 4, and we'll compare that to the graph of our parent function y equals the absolute value of x. So starting off, what I like to do is when I write my equation, I'm going to be thinking about what are the things that are going to transform it. So I have my negative 1/3, so I'm thinking to myself that will be the y values will be multiplied by 1/3, and then I also have to reflect it. And remember, it's the reflection across the y equals. So then when I move to my x, and then I need to remember that it is a minus, so my negative 2, which is negative minus a negative, is a positive. So I'm thinking to myself, that's in that same position as my minus h, and that will be that translation left and right. So this one will be a left 2. Then we have a minus 4 here where the k is, and that would be down 4. So what we've actually just done is we have compared it to the parent function. So I'm going to kind of walk through that. And so my first thing I'm going to do is I like to start here at the up and down. So that would be a translation down 4. My second step will be kind of another translation up, no, left, sorry, I had to think about that, left 2. And that's that minus 2. So we don't say it left minus 2 because then we're taking a double negative and going positive or to the right. So right here, our translation though is left 2. Then I'm going to talk about the y values. So y values are times 1/3. Now I left that negative out because we're talking about just the y values are going to be a third of what they normally are. So if it's say up 6, it's going to be up 2 instead of up 6. And then the last one, I break it into 2 parts, is that reflection. And that's that negative in front of the 1/3. A reflection, and we break that out to its own specific transformation, because that's what's gonna, and it's reflected in the y equals, and that reflection y equals is this up and down, because the y values, the y change up and down is that negative 4. So it'll be y equals negative 4 will be that reflection line. And once we kind of get down there, it'll be more understanding where that comes from. So I'm going to take my vertex, and because that's kind of our key point. But as I'm doing that, I'm thinking that it's going to be all of our points along that. It's just that this one is kind of a key point to help us organize our thinking. So we're going to go down 4 and left 2. So I'm going to put my point there, and normally my line then would go over 1, up 1, over 1, up 1, and we'll kind of continue it out up in this way. But that would be the next, my y values are times 1/3. So as I'm kind of thinking about that, I'm going to start from that vertex, and here is that horizontal line that we're thinking about, that y of reflection across that y is negative 4, because this is our horizontal line that'll reflect across. But I'm going to do the 1/3 first so I don't make any errors. So if I go over 1 from my vertex and up 1, I'm going to do a third. It's not a nice point. It's just kind of a fractional in between. So I'm going to go over to over 3, up 3, because if I take a third of that, it's a nice crosshairs that I'm going to be able to get a nice point that I'll be able to reflect across. The next one would be 6, because it works nicely with a third. So up 6 would be 2. A third of 6 is 2. A third of 9 is 3, so that would be 3 up. And then 12 would be 4. So I'm going to go all the way across to the edge of my graph to get as many points so that my line is accurately drawn. So now I'm going to go the other direction, over 3, up 3 normally, but we're going to multiply that y value times 1/3, so 1. So over 6, up 6, and a third of that would be 2. So we're going 2 up from that horizontal line from the vertex, and then that would be my last one. The other one would be somewhere over here. So now this is going to be my reference line that I'm going to then reflect across that y equals 4 here. So I'm going to do that in red as my final answer. So my vertex gets reflected 0 away, so it's 0 away down below. If it's 1 unit above, it's going to be 1 unit below, so that's that minus. It's reflecting across that y equals -4. 2 up would be 2 negative. 3 up would be 3 negative. From that line of reflection, 4 positive would be 4 negative. And then same thing on the other side. And then we will draw our nice straight line, getting our points lined up as accurately as we can. There we go. And then, oh, I forgot my arrows. So I find it much like more helpful to have the comparing done first before I go and graph it, because that gives me my basis of what my graph is like, what are the transformations happening in the graph. And so with that, what we can do then is create a nice graph, that final graph. So it is wider facing down. That facing down is that minus that negative here, which is the reflection across y equals -4. The wideness, it's wider because it's a times 1/3. So the y values are shrinking. I've translated it left 2 and down 4 in my h and k. So again, it's y equals a, absolute value of x, minus h, absolute value, plus k, where k is your up and down, h is your left and right. This has to be subtract, has to be, to be, subtract. A has two kind of function. It's the y value multiplier, and it is also the reflection. And remember, the reflection is in or across the y equals number, and that y equals number actually is our k. So we can actually just take the number right from that k in the back and put it right over the y equals 0.